My name is Branson Mikuleski, and today I'm going to be doing my final project for my class Data Structures. And the final project is going to be technical interview. And the prompt I was given for this interview is prompt number 17, simple calculator. Given a string containing digits and plus or subtraction operators with no parentheses, write a function to calculate and return the result. And here we are given some example inputs and outputs to kind of guide us for what we are looking for. 1 plus 1 should output 2, 2 minus 1 plus 2 should output 3, and so on and so forth. And so the questions I have just looking at this prompt right off the bat is, do we have to follow order of operations? When thinking about calculators and stuff and how important it is to input your numbers into it so your output is what you desire, it's something to note. Do we have to follow order of operations, or PEMDAS? And considering that we are only working with addition and subtraction, and we're not working with parentheses, order of operations actually does not apply to our prompt here. We're not working with multiplication, division, exponents, or parentheses. So we can work left to right through our strings as we would, and not have to worry about following PEMDAS. So that's nice. We don't have to assign indexes for our numbers. We could just work straight through them left to right. So that is nice to know and nice to consider. Another question I have is, do I assume there are going to be digits or numbers that go beyond, I guess, 9? So, for example, is there going to be a prompt of 234 plus 35? And the reason why I ask this is because when we have to parse through these strings, because these strings are not numbers yet that we can work with. They are actually just characters. So we're going to have to parse through each string, turning them into numbers and values, integers we can work with. It's important to understand, like, do we have to work with numbers that are going to be larger than 10? And for the sake of efficiency and just having a strong calculator that can work with anything, it's not confined to anything besides, well, of course, addition and subtraction, I will say yes, we are going to be working with numbers that are beyond 10. So with that in mind, the first thoughts I had with this prompt is I was going to use a request function to input numbers manually, and then we could go about it that way. But come to find out very quickly, LeetCode doesn't actually use input methods or the request functions because it automatically returns arguments. So you can't use a request, and you can't go in the terminal and input numbers like you can in VS Code. So I quickly found that out, which actually I'll discuss later in my trade-offs, which is actually very nice, considering that the structure we're about to use is actually a lot more efficient than that would have been. My other thought is we're going to have to turn these strings that are currently characters into numbers that we can work with, because we cannot just work with these as they are right now, because they're just characters. You can't add a character in a character. That's the same as, like, what's S plus D? It does not work. Unless we get into variables, but it's a simple calculator. It's a simple calculator. We don't have to worry about that. So I guess my approach for this is going to be, since we're just working left to right, we don't have to worry about indexes, and because we're only working with addition and subtraction. We are going to parse through each of these strings. We're going to turn them into values and numbers that we can work with, and then using our if statements, we're going to follow that operation using the operators, and we're going to continue to add on to our loop suggestive of however many integers we have in the string. So let's just go ahead and jump right into it. We're going to create our class. We're going to go ahead and call it simple calculator. Very original. Very original. And we're going to go ahead and define our first and only method for this class, which will be calculate. Makes the most sense. And we're going to pass the parameters through of self, as you do with any method. And we're going to go ahead and pass through s, but we're going to tell our method here that whatever is put for s is actually going to be a string. So our method is now going to expect a string of values instead of just one. That way we don't have to input each value independently, like work with nodes or anything. This will actually be a very simple way to work with this. We're also going to tell our method that the result is going to be a integer. Okay, so let's go ahead and give our method a starting point. So we're going to start everything, or we're going to start our current number, our current value at 0, our resulting value at 0. This gives it a fresh reset, and we're going to give it a current operation of addition, or plus. And the reason being is because when you're starting a new calculation, you want to start from 0, and you want to add on the first number of these strings to that. So that way you are getting the output that you want. If we were to do negative here, you would subtract 2 from 0, and it would be -2 minus 1 plus 2, and that would not get you 3. So that's why we are using a operation of plus to start our method. We're going to go ahead and add to the end of our string of every string that's inputted with another addition sign or plus operation. That way it completes the string and every value is accounted for. And then we could go ahead and start our loop, and we can parse through our strings. So for every character in our string, we are going to see if those characters are digits. This will return all the characters that are digits, and we'll go ahead and, wow, that's not what I want to do. And we'll go ahead and return them as integers or numbers. So our current value will now become whatever the first number in that string is, plus the integer of the character. Okay, now that we have parsed through and turned our characters into digits, now we can work with our operations. So if the character is either a plus or minus, so when it goes to the string and it sees a plus or minus, it will follow these, or it will pass through these if statements. So if the operation that it comes across is a addition symbol or plus, it's going to add our current value to our result, which is the previous, since we're working left to right, it would be the previous operation. And then if our operation is subtraction or minus, it's going to subtract our current number from our result. Okay, there we go. And now, just so we can reset everything after one operation is completed, before it moves on down the line in our string, we want to go ahead and reset it. So we're going to put our current value back to 0, and we are going to put our current operation just back to character. That way it can continue to read down the string. And that should be it for our method. Let's go ahead and close our loop. We're going to, by returning a result. And let's go ahead and test our structure. So to call the class, we'll just go ahead and just use test. And we will call our class. And we will go ahead and print because we want to see if it works. And we'll go ahead and calculate some of these inputs that the prompt gave us, and then some of my edge cases. So let's just go ahead and we'll just 1 plus 1. Pretty simple. So if we input that, okay. Oh, there's a problem. Digits is not multiplied when calling this method here. It's just is digit. There we go. We fixed it. 1 plus 1 is 2. Output's 2. That's our desired output. What if there's more than one operation going on? 3. Perfect. That matches our desired output. So with the test cases it gave us, we were able to successfully complete the prompt. But what about, let's just say there's a bunch of white spaces in the middle of a string. What happens then? It still outputs 3. That's because when we are parsing through our string, the only thing that is returning is the operation or the digits. It will check to see if these are digits, and if they are, we will turn those into values. So it doesn't actually account for any white spaces, which is super nice. Kind of gives the user, I guess, freedom to put as many spaces as they want. What about earlier when we talked about what happens if we use integers beyond 10? So let's just say we have 765 plus 2. 767. That makes sense. So we've successfully parsed through our string, taking all the values and turning them into numbers that we can use for our operations. So we have successfully completed this prompt. The time complexity we have here is a big O of just n, because we are looping through however long the string is. So if the string just went on forever with a lot of operations happening, that would affect the time complexity. So it's all dependent on how long the string is. However, our space complexity is actually constant, and that is because we have a big O of 1. And that is because we're not defining anything and we're not storing anything. We're not storing anything to lists or dictionaries. We're not taking up any space. We're just we're going on down the string and returning that output, and then we are finished. We're not storing it anywhere. Of course, if eventually when you want to use this for any sort of function, then that would affect it. But for right now, this actually has a space complexity that is constant, which is actually going to segue into my next topic, which is trade-offs, because as I mentioned earlier, I wanted to do a request function, requesting the user to input the values manually. That would affect space complexity because we would have to use lists to store our numbers and our operations, or with the request function. So we would actually be storing stuff into lists. You'd have to be inputting numbers manually instead of just typing out the entire equation and inputting it. You'd have to do store 765 plus 2. You'd have to do that manually, which would be very time consuming and not efficient. So being denied that ability to use the request function actually was very useful in our trade-offs, because now we have a much more simpler, much more efficient structure here that does the exact same and, in my opinion, does it better. So thank you so much for listening to me. I look forward to hearing your feedback, and I hope you have a nice day.